Viewers like you make this program possible. Support your local PBS station.
So, Bob, we're ready now.
I'm not.
Okay.
Okay.
Yes. So why don't we start, Bob? How do you tell people about what it is you do and what it is you discovered?
My voice won't be any good, but I tell them I've always been excited about natural history. That I learned to be an observer as a child. And just by being out there, being vigilant, know something intimately, one recognizes change. Why is the world we know so well changing?
One of the greatest gifts science has to offer is a way to make sense of our world. The big names, the names that are etched into the columns of museums and buildings, Newton, Darwin, they saw the world in such a different way than what had come before. As I researched this story, I discovered a handful of people you've never heard of, who went out into the world and saw things that nobody had seen, thought things that nobody had thought, and what they discovered will change the way you see nature. And at a time when stories about the environment are all gloom and doom, this is a unique story of hope, and one we'd be very wise to hear.
When I was a child, I was severely myopic from who knows what age. I didn't know that you could see leaves on a tree from the ground. I remember my parents and I were standing at this lake in New Brunswick, and there was a moose on the other side of the lake in full view of my parents, and I couldn't see it. And they said, "What? You can't see that? What's wrong with you?" But something happened before I got glasses, and that was that I was let loose with a mask and snorkel.
Hey, Mary, come on. Look, Mom, there's fish in here.
For the first time, I saw things clearly because of the refraction of the water. There was a lot of beauty, and it was all sharply focused. You can imagine how beautiful it would be when you see detail that you'd never known you could see. What were pond weeds above the water were forests of stems under the water. And in this little forest, there would be sunfish. Then occasionally a big, larger predator like a pickerel or a perch or a bass goes by. It was a flashbulb moment, as they say, where I just had to be underwater looking at life that way for the rest of my life. At the time, there were dozens and dozens of really strong ecologists working in coral reef biology, but nobody was doing underwater ecology in rivers. And that's a who cooks for you owl. Who cooks for you? I actually think it's incredibly important that we understand where the world's going, how we're affecting its ability to sustain. I try to go out looking to see how the world works.
I remember one day I played hooky. I was called one evening by an acquaintance who told me that a Bachman's warbler had been seen that day at a place called Poet Creek, which is south of Washington on the Virginia side of the Potomac River. I announced to my parents, I didn't ask, I announced I was taking the car. At 4 o'clock the next morning, I wasn't going to school. Walked down the little path that had been described to me, and then I heard the bird. The sound was just as it had been described to me. See-see-see-see-see-oo. I knew it was a song I'd never heard before. I walked right to it. There it was, and I watched it for a couple of hours. Even then, it was just a mythical bird. I don't know another living human being who ever saw one of those birds. It's a memory that's about to disappear from the earth. I loved being in the forest. Not see people, just be in the forest. I got to know the good bird watching spots over, I'll say, a 200-mile radius. One by one by one, I saw all those places go under the bulldozer. I watched the birds just disappear. It's just nothing like it in the way it used to be anymore. That is the disquieting source of a lot of my motivation. When I was in university in the earliest 60s, we had already altered North America so much that there wasn't any place in it where nature was operating in a free-running manner the way it had through evolutionary history. I began to search for a place that was not at all disturbed by human activities. You have to go to the end of the earth to find these places. There are so few of them left. That was where I felt I was really running against the clock, that if I didn't get there now, I could blink my eyes and it wouldn't be there anymore. I went to Peru in 1963. That's when I found Manu. There was a brand new national park about to be opened in a corner of the country I'd never been to. I was stunned. I just was overcome by it. I had never seen anything like this before. Instead of one spider monkey in 10 years, I could see 10 spider monkeys in 10 minutes. It was that extremely different. Out in the forest, you encountered 2 or 3 groups of white-lipped peccaries a day. The contrast just left me staggered. It's real nature that nobody has tinkered with. There are not many places like that anymore. We had to learn about how nature operates. That's why I settled down in Manu, and I've been there ever since.
Everybody has to do something. I was actually thinking about doing a lot of things other than biology. I was thinking first and foremost about surviving, making a living, being able to make my way in the world. One of my former professors at Washington State was a consultant with the Atomic Energy Commission, and they were looking for somebody to go out to Amchitka Island and work on sea otters. I had never worked in the ocean. I was not a marine biologist. I knew nothing about the ocean. And he said, I think you'd be perfect for this. 2 weeks later, I was on my way to Amchitka Island. There's a sign when you get off the airplane there. Not the end of the world, but you can see it from here. I had this feeling of both excitement for the beginnings of a new life, of doing something out there, and also an incredible sense of trepidation over whether I would succeed or not. Part of the goal was to survey the otter population. Another part of my goal was to document and measure the composition of the marine community underwater. The kelp swaying, all of the invertebrates, the color. It is absolutely one of the most amazing scenes that I've ever seen. It is spectacular. Kelp to the coastal ecosystem is like redwoods to a redwood forest or oaks to an oak forest. It is an important foundation for all of the other species. These animals, to the degree that there's a place with my name on it on the map of ecology, they're the ones that got me there, you know. Without them, I don't know what I mean, I might have gone some other way, but yeah. They don't know that.
In 1965, Serengeti was not well known. There were hardly any tourists. People weren't aware of the remarkable nature of that ecosystem as they are now. I got a grant from the Royal Society to pay for me to go out there. That is where I started my work on the birds and the migrations of birds in Serengeti. All of these species all mixed up together. It was just too good to be true. I'd longed to be in such a place ever since I was a small boy. I realized that it has been like this for hundreds of thousands of years. It was magic. I wanted to find out why. The other scientists had been doing a count of the populations of large mammals, basically the first counts of animals in the Serengeti. None had been done properly before that. They found the populations of wildebeest, buffalo, elephant were all increasing at a very fast rate. For a large mammal, they just don't do that sort of thing. This is just not what one normally sees. Why were they increasing? They turned to me and said, "Would you like to study buffalo? Can a birdman study buffalo?" I said, "Of course. I'll study anything."
When that red shows, it's ready to fire. And if I get drug in my face or something coming back from the dart hitting the animal, and I go under, get that one here with the clear liquid, okay, and 3 cc's inject that straight into the person who's got the drug, if that's me.
There's now a mystery to solve. I've always said that science is detective work, but at the time we started, nobody knew anything at all. I didn't want to just describe it. It's not what we call stamp collecting. That is, what lives here, what are their names, and move on. It was, why is it like this? And that was very important to me right at the beginning. As I worked on the buffalo over the next 3 years, it became apparent to me that I had to understand what the wildebeest were doing, because the wildebeest had so much impact on the buffalo. They were consuming the food supply of the buffalo, and therefore had to broaden my horizons and start looking at the wildebeest. I needed to know the rules that kept Serengeti together.
When I began writing, my angle in was through the Serengeti and the work of Tony Sinclair. But as I dug further, I discovered a remarkable band of initially young scientists who went out into the world and just followed their passion and their curiosity. But Jim and Mary and Tony and John, they don't know each other. What will eventually tie them together is one man, this fellow named Bob Payne. Bob Payne is a brand new professor at the University of Washington. He's out there following the tradition, observing nature, measuring, recording. But Bob's got a more radical idea. Bob wants to test how things work by changing nature. He was exposed early on to the general idea that the way the world worked was that the plants took the sunshine, turned it into food, and some animals ate those plants, and then some predators ate some of those plant eaters. That was really the structure of the world, from the bottom up. That plants were the foundation of nature, then the plant eaters, and then the things that ate the plant eaters.
Just outside of Ocean Shores, that's holding up traffic along the 101.
But Bob wasn't sure that was really the way things worked. He thought predators could be much more important. They weren't just passengers riding atop food chains. They might be drivers. Bob was really gripped by the idea of testing. Maybe predators do something more than just simply collect a little bit of meat in a food chain. But how do you test that? You're not going to empty the ocean of all the sharks. You're not going to take all the lions out of Africa. How can you test the importance of predators? He's got to find some system that is contained, almost like a laboratory. And when he found Macaw Bay in the Pacific Northwest, he saw these tide pools and he thought, aha, this is it.
there it was, spread out in front of me. It was nirvana. This magnificent array of organisms. There were carnivorous gastropods feeding on barnacles. There were sea urchins feeding on algae. There was a lot of pattern.
Other species were chitons and certain snails and certain kinds of algae, about 15 species in all. What was really important was that there was one major predator. And the predator in question is a starfish. They come in two colors, purple and orange. And you'd sort of think, oh, what a lovely starfish, but inside is the heart of a fierce predator. These starfish are massive consumers. They eat barnacles, they love mussels. This is the lion of the tide pool. He found his laboratory. Payne did one of the simplest experiments in the history of biology, which was to remove the starfish from the rocks in one place and not in another. Month after month, he went back and visited that site, tossing starfish as he needed. And very quickly he saw the community was changing. The mussel beds were expanding. Species disappeared from the community. And after several years, all that was remaining were mussels. From 15 species, it just became a monoculture of one species. The starfish has this huge effect. Without the starfish, the community essentially collapses and simplifies to a single species. So it was the predator that was responsible for the diversity in the tide pool. Instead of being organized from the bottom up, the starfish drives the system from the top down. Bob discovered a whole new way of looking at nature.
I was excited. I knew I'd produce something remarkable. I didn't know how far it would go. But when the leading ecologist at the time, a man named Robert MacArthur, basically said, "That's terrific. I believe you," I knew I'd struck gold.
When Bob did his experiments and removed the starfish and other species disappeared, well, that said, wait, the starfish is really important. But what's also crucial is that Bob did other experiments where he removed other components of the system and nothing happened. So the clear message from his experiments are that some animals are more important than others. Those animals he called Keystone species. Because just as the keystone in a Roman arch, that when you remove it, the whole arch collapses, when you remove the Keystone species, the whole community collapses. The existence of other things in that community are dependent upon the presence of these Keystone species.
In trying to be a little bit of a smartass, I went back to George Orwell, Animal Farm. And I think it's all animals are equal but some are more equal than others. That's true. There are a lot of animals out there, but some play major roles, some don't.
He laid the foundation. He made the first observations that were the reference point for everyone afterwards. The quest now becomes, is this a general phenomenon? Is this a rule of life, or is this a peculiarity of a tide pool? This is what he's got to find out. But he's not going to figure this out by himself.
Bob had come to Amchitka Island. I met Payne the day that he got off the plane, and the instant I met him, I thought, there's no way I'm going to talk to this guy. He just scared me to death. He was very smart, very intimidating. And he said, you want to sit down and talk a little bit about what you're doing? I told him that I was interested in following this notion of how the kelp forests could support so many otters. He said, yeah, it sounds pretty dull to me. Why don't you think about these animals as predators? It just immediately occurred to me that this was a phenomenally interesting natural experiment. And that was sort of the beginning of the rest of my life. Bob planted the seed of looking at the effect of otters. It naturally occurred to me that the way to do that would be to go to some place where they didn't occur and compare that with where they did. If the otters are having some big effect, I ought to see it. If I go to a place where they don't occur, I ought to see it. I had to try to find an island where the otters have disappeared. What I understood about the distribution of otters was that they occurred throughout all of the islands to the east, but they weren't on Shemya at that particular time. Shemya lit up like a red flag. It was the obvious place to go. I stuck my head in the water at Shemya and I thought, oh my God, this is unbelievable. I'd never seen an urchin barren before going to Shemya. From having watched otters for extensive periods of time, I knew they ate a lot of urchins, but it never really occurred to me until I actually saw a system where otters were gone that the effect was massive. Kelp forests, like forests everywhere, provide habitat for other species. A place to escape predators, a place to lay their eggs, just like birds, just like many other species in terrestrial forests. The urchins ate all of kelp. Otters eat urchins, urchins eat kelp. You take otters out of the system, urchins become abundant, and they eat all the kelp. You can't have a kelp forest without having sea otters there to protect them. I sat there all night long. I didn't sleep at all that night. All I did was write. I think I had some sort of visceral sense that this was a major deal. I've never in my life felt such enthusiasm and excitement as I felt at that moment.
I'm coming to Oklahoma pretty inspired by Bob Payne. I was a student of Bob's in the 70s, so under Bob's instruction had read the amazing papers of Jim Estes that had just come out a few years earlier. But to be honest, I was doing something completely different. I wanted to see what fish did because I liked them. It was really getting a chance just to watch fish, as opposed to having to prove that fish matter. I just wanted to see what they were doing. But you look down into this particular stream, and what we saw was these barren pools, interspersed with these emerald green pools. So what's going on there? We did get into wetsuits, and the first pool did happen to be a green pool. You could just look through the waving fronds, and lurking in the forest are these big, largemouth bass. There weren't many prey in these bass pools. They'd cleaned out the prey. And then you go to the next pool, and it's just about as deep. It was completely barren and sandy. And there are these little thin minnows that were grazing algae away down to the bare rock. We didn't even need to snorkel to see that there were no bass in it. I knew it was a Bob Payne Estes situation when I first saw it. All you have to do is the experiments that Bob advocated. We took a green pool, split the pool into two halves. We netted out the bass, and then we added minnows just to one side. And we sat back and waited. Doing manipulative experiments or even thinking this way is not widely practiced. It's important to try to convince people who are not willing to entertain another view that they should have a closer look. There's this wonderful sense of beauty, awe, fascination of nature, and then the fun of doing a kick it and see experiment. In 5 weeks, on the side where we'd added minnows, they chewed it down. It was totally barren. Just takes one bass in a pool the size of a large room to either terrorize the minnows and make them leave or eat them up and turn it from barren to green. Bass are Keystone species just in the sense that Jim's sea otters or Bob's starfish are. It was pretty obvious that predators do matter. This is Bob Payne's Keystone species as realized in a little prairie stream in Oklahoma.
Mary Power's work in streams, Payne's work in intertidal, and Jim's work in the environment of the ocean. They did seem to work in a wide range of aquatic environments. So at that time, I started daydreaming, how could I expand on this? What I needed was to do an experiment, but on land. That meant finding fragments of forest without any predators, but with everything else still there. I didn't know of any such place until I learned about Guri, and that's where it all began. Guri was a huge lake in Venezuela, created by the damming of the Caroni River. It produced lots and lots of islands, mostly without any predators. The top predators, the mountain lions, the jaguars, and harpy eagles, they'd already disappeared. Everything that should have been there was there, except for the top predators. It's the perfect system so that you could see what the response to removing predators would be. When I climbed up and walked into the forest, it looked like a hurricane had been through there. Wow. There were some islands that had accumulated extremely high densities of leafcutter ants. On the mainland, leafcutter ants are controlled by a species of army ant. Without them, they're 100 times more abundant than they would be on the mainland. Foliage had been stripped off the trees so many times by this multiplicity of leafcutter ants. All the storage reserves of the trees had been exhausted. They'd leafed out and had been defoliated, and leafed out again and been defoliated. A tree can only withstand that so many times, and then it dies. That is absolutely a response to the absence of predation. They start out this beautiful green forest, and in 20 or 25 years be reduced to dead rubble. Look at that. Look at all those trees. This one has died, that one has died, this next one has died, that one has died. The overall impression is mortality. We saw it happen on island after island. It was repeated in different ways with different actors, but it always got the same end result. It's all predation driven. You remove predators, then it leads to the deterioration of the whole system.
What Jim and Mary and John all confirmed in really different systems was that predators were really important. That's a totally new way of looking at the world. It overthrows preconceptions about the picture we had of nature. It reveals completely unexpected, hidden connections between creatures and nature.
But that's just the beginning of the story. The first glimpses of the chains of connections between species. The real question is, how big, how deep, how far do these connections extend across our planet?
By the early 1990s, I was of the mindset that otters had reached historical levels and that they were stable at those high densities. If someone had told me at that time that the system is going to collapse, I would have thought, this is insane. How could that possibly be? But I knew that there were 8,000 otters at Amchitka Island, and 5 years later, they're almost all gone. I was just stunned. It was like going to a whole different ecosystem. It's a dense kelp forest, and then all of a sudden there is this abrupt change. That was the case across the whole Aleutians. 50,000 miles of coastline. It was a massive decline. We're talking about the loss of tens or perhaps even several hundreds of thousands of otters. A decline of 95 to 99%. And not a single corpse or carcass to be found anywhere. I knew they weren't dying and crawling up on the beach and starving to death or dying from some disease because we would have found them. So then the question became, what happened to the otters? It was such a dramatic event that I had to try to figure it out. The most striking thing that we saw was that there were killer whales all over the place around these islands at that time. I would see a killer whale on average of probably once every 3 or 4 years in the 70s and 80s. Starting in about 1990, I'd see them 3 or 4 times a day. Not only did we see killer whales, but we started seeing them eating otters. One day, our field crew was out here, and there was a group of otters that were hauled out on these rocks immediately ahead of us. The observers noticed off in the distance 3 killer whales that were coming from the north, and the killer whales swam up in tandem, all 3 of them, right to about here. 2 of them dove, and once they emerged again on the far side of these rocks, the 3rd killer whale charged the rocks and created a big wave that washed the otters off into the water, and the killer whales that were behind grabbed 1 or 2 of them. That behavior has been seen in killer whales with other species. We began to suspect that killer whales were the driving force or the cause of the decline of sea otters. Once we came to that conclusion that it was predation by killer whales, then the next question was, why did that happen? What made them do this? I also was aware that other species had declined in that system, and in particular stellar sea lions. It wasn't a big jump in logic to imagine that the sea lion populations had declined for the same reason, that orcas had simply driven their numbers downward. I was in my office one day and actually plotted the graph, and I remember sitting there looking at this thing, thinking, oh my God, this is amazing. It was whaling that started this whole business. In the North Pacific Ocean, where this event occurred, industrial whaling began post-World War II. And it progressed through the early 1960s. By the early 1960s, the great whales of the North Pacific had been decimated. Taking the great whales out of the North Pacific, which are large and highly nutritious to a consumer like an orca, really shocked that system. That would force killer whales into broadening their diet. So it all fit together. Whales got stripped out of the system, killer whales got hungry, they started feeding on other things. First thing they ate was harbor seals, cleaned them out. Next thing they started feeding on was stellar sea lions, cleaned them out. Went to the otters, cleaned them out, and that's what we saw. These effects seem to sweep through the system and impact virtually everything. From salmon, from seabirds, from bald eagles. The whole system collapsed. That was sort of a revolution in my scientific thinking, was recognizing that nature is connected over such vast scales of space and time in such major ways. It was very clear what had happened. The cause was simply the removal of great whales. People were the cause.
Holy shit. A set of dominoes that we set in motion 60, 70 years ago have come all the way around and bitten us in the ass. These systems are hundreds of thousands to millions of years old, and we've come in and pulled them apart. These are whole new eyes for looking at the world and figuring out what's going on. Why and how is it changing? What have we done?
What humans have done is take nature apart, layer after layer.
It is very much like a thread in a tapestry that if we pull the thread, the whole thing can come unraveled. There's widespread evidence that the world is changing. We're experiencing extinction, we're experiencing declines.
Even in national parks that were supposed to conserve biodiversity had lost species.
Why does that matter? Because it matters beyond the emotional loss of a species. If you lose the wrong ones, if you lose the keystones, you're going to see very big changes everywhere.
It was after we understood that we coined the word downgrading to describe it.
Much of the world that we see today has already been downgraded.
Almost any place that we've touched is downgraded for a host of reasons. domino effects are probably what scares us the most. We thought we were only removing these inconvenient, scary animals or the large, tasty things out of the ocean, but in fact, we were having all of these strong indirect effects on other creatures and other systems. There is a risk that we get used to a downgraded landscape as the norm. A treeless landscape in Scotland is not a baseline, it's a sickness, it's a cancer. Cancer is the uncontrolled growth of something that becomes pathological. Algal blooms on lakes are a cancer. They're running unchecked, and they end up suffocating out other forms of life in the lake. In West Africa, you have baboons overwhelming areas because top predators like lions and leopards have been exterminated. In America, deer are destroying the forests. Even national parks are downgraded. We've only just realized after 70 years without wolves, Yellowstone is not what it's supposed to be. I know we like Bambi, but the reality is elk herds and deer are running unchecked, and they've had devastating effects. It's not normal. This is what this band of scientists illuminated. These hidden interactions, the stuff that has escaped our eye, the stuff that wasn't obvious to us, that we didn't suspect at all. Most of us can't see downgrading even if it's right in front of us.
I can see it. I'm not sure just anybody can see it. Science can tell us what's happening when the naked eye can deceive us. Remember, we found at Guri that with no predators, the herbivores increased and the ants literally ate down the forest. We're seeing the same thing here. It's not ants, it's deer, but out of control, they can lead to the same rather disastrous consequences. The deer have reached plague abundance, and it's the deer that create this effect, as if you had taken a hedge clipper and gone along on the underside of the branches, removing everything between the ground and what we call a browse line. If this forest were whole and natural and reproducing normally, you wouldn't see me from the camera. There'd be things in between, but you can look way out there and there's no obstruction. The visibility is 100 feet or 200 feet. It should be maybe 10 feet or 15 feet. That's the difference. There's nothing in the middle. There are the trees overhead and a few little plants on the ground, but the middle is missing. This forest is clearly on the downgraded side because it's a disappearing forest. These big old trees, they're the last of their generation. When those oak trees die off, there wouldn't be a forest there anymore. The end point of excessive deer browsing is not just the loss of the forest, it's the loss of the whole forest system. All the other things that live with the trees. I remember a better world, and now I see things going in a direction that disturbs me enormously every day of the week. I can't stop thinking about it. Where are we going? What's the future going to be? Will there be any nature at all in the future?
We've broken nature all over the world. But this could be the part of the movie where, oh my goodness, this is the gloom and doom you hear 10 times a day. The headlines are all too familiar. You know, we're doomed, we screwed it up, we're awful, nature's gonna disappear, etc. We shouldn't be getting used to these things. They're not the way they need to be. They're not the way they should be.
Downgrading is a fact. But is it our destiny? Or is our destiny still in our control? Can a downgraded system be upgraded? Is that even possible? When Tony Sinclair started working in the Serengeti, he didn't realize it at the time, even the world's most famous national park was badly downgraded. But it was changing.
We know that 120 years ago, an epidemic called rinderpest hit the wild animals of the Serengeti. Rinderpest is a disease of cattle. It is not a disease of wildlife. It's very similar to measles. It kept the wildebeest population down for the better part of 70 years. That was a definite form of downgrading. In the 1960s, veterinarians successfully managed to eradicate rinderpest in most of Africa. We realized that because rinderpest had disappeared, that was the reason we saw the populations increasing. When I first started, the wildebeest was somewhere around 250,000 animals. By the time I'd finished 3 years, there was 400,000 of them. And everybody thought, well, they must have reached their limit. The next time we looked, it was 700,000. 4 years later, they had doubled again to 1.4 million. We had a world record, the largest population of ungulates in the world. I sent a message to a colleague of mine what the number was. He wrote back, all it said was, in reverse, fan-fucking-tastic. The meeting in 1982 was our first opportunity to tell the world about what was going on.
We are game managers, and that is what we do. We manage our resources. That's the end of my time. Thank you very much for listening, and thank you for the contribution.
You know, we'd just broken the record. We're the biggest population in the world, and that was quite something.
Our next speaker is Mr. Tony Sinclair from Tanzania.
And this was an eye-opener for all of us.
I'm here to share the success story of the Serengeti.
I made this presentation with a lot of enthusiasm.
To 1.4 million.
There was a deathly hush. I wasn't expecting that reaction at all. Everybody thought we were being irresponsible to allow this to happen.
Surely you can understand this.
We should have been culling these animals because they'll overgraze the place, destroy the habitats, and they were going to cause a collapse of the system. But why should humans have to interfere? These systems have been in existence for millions of years without having humans required to interfere for them to persist. We decided we were going to stick to our guns, and we prevailed upon the park authorities not to give in to culling, but to wait and see what was going on. If we were wrong, we could be destroying one of the iconic places on Earth. I returned, and we did another census, discovered that we had got the same result as the year before. 1.4 million. Now, this was the very first time that had occurred and suggested that the population was now leveling out. But we had to come back another time, one more time. And 2 years after that, we came back and found we got the same answer. And at that point, we knew that the system had leveled out of its own accord. And there was no damage to the environment. It was not collapsing. And then, to our surprise, we found that the system was actually repairing itself. All of a sudden, things started to reconnect with each other. Wildebeest produce dung out on the shortgrass plains. That puts fertilizer into the soil, and that fertilizes the grasses. The grasses then become highly nutritious. And by eating up the grass, there was less fuel, and therefore less burning. And that allowed the tree populations to increase. Tree populations that probably hadn't occurred since the 1800s. Those trees provided more food for elephants, for giraffes, and for many, many bird species. And then there are many more predators because there's more food for those too. All these components were interconnected, and they were all responding to the wildebeest population. The wildebeest in their huge numbers were determining everything else inside the park. I realized that wildebeest was a keystone. Bob Payne had always assumed that keystones had to be a predator, but we realized that a keystone could actually be herbivores. We were seeing a recovery, an upgrading of the whole ecosystem for the first time.
Even though wildebeest have been taking a pounding for 70 years from this virus, that there was still the resilience there, still the capacity there for the population, when that was lifted, to explode. And that when it did explode, the capacity was still there in the Serengeti for the Serengeti to change in profound ways. More trees, more giraffes, more songbirds, more butterflies, more dung beetles, more across the Serengeti.
Tony's work is marvelous. I was delighted because here is recovery, here is upgrading. But it's a long process. It's taken 50 years. We're almost 60 years down from Bob Payne's work with the starfish. I think we're finally arriving at a much better place, but it has taken that long. That's what gave me the idea for the White Oak Conference.
John approached me about getting a bunch of people together. The idea was to invite people that were prominent ecologists in various major ecosystem types around the world.
It was only by listening to each other at White Oak that we realized we were talking about the same thing. And that, I think, is one of the major areas.
Whether it was terrestrial or aquatic, whether it was Arctic or tropical, it was all working in the same way.
Every person that was there wasn't anyone that argued, I don't see this in nature, not a single one of them.
The White Oak Group published an article in Science magazine titled Trophic, Downgrading of Planet Earth. Bob Payne was the first one to show it. Throw away the starfish and the biodiversity collapses. The starfish is critical. It may sound strange, but that is the way nature works. Everywhere.
There are rules. No one can escape it. If you have to fix something, you have to know what's broken. That's what rules provide.
And so our challenge will be to understand how we can upgrade systems that have been downgraded much farther than Serengeti. What we need to do is put the starfish equivalent back in.
It's critical that we replace species that are central in holding ecosystems together.
Nature could heal itself if a keystone is released. It is a place where you could get an enormous bang for the buck.
We've found the rules. We've found the rules, how systems work, how the world works.
Now you've got discoveries that connect with one another and truly change our view of how the world works. And now you've got a chance for a scientific revolution.
And what does this mean for you and me? It means we can use this knowledge to upgrade the places around us. And like in the Serengeti, the potential is enormous. I'll show you something really amazing. In the high plains of Argentina,
where pumas are allowed to return. The grass grows and creates habitat for all sorts of creatures.
one picture, a lot of hope.
Wolves have been missing from Yellowstone for 70 years. There was no reason for biologists to be confident that you put wolves back in there, that anything would happen.
But we put wolves back in, and the willows rebound. The aspen are doing better. The cottonwoods thrive. Beavers come back.
Oh my goodness.
This is an incredible photo. This is an enclosure that was built in Scotland that shows you the impact of the grazers
on what Scotland would look like without them. Many of the trees in Yellowstone need wolves. The trees in Scotland will need wolves. But this isn't about making the world pretty. This is about making the world productive and functional. And the body of knowledge, the number of examples is growing.
For instance, in the upper Midwest, there are folks adding Keystone fish back into lakes and flipping them so that murky green lakes become clear. Where the otters are returning to the Aleutian Islands or anywhere on the west coast of North America, the kelp is coming back. In rice paddies, spiders are keystones. So if you want rice to eat, protect the spiders.
All over the world, people are trying to improve things that were degraded in past decades. We've seen it's possible in so many places in so many ways. So, very modest ambitions by individuals driven out there into nature has paid off in a grand vision of how the world works.
Humanity ultimately is the driver of everything. These keystones are really important to the distribution and abundance of species, but all of that is under the control of humanity. Humans are hyper-keystones in the sense that they are all controlling, and they are all influencing of these things.
The behavioral change in humans that I think is most important is changing intolerance to tolerance. It's not an idea that's really been part of our history. We exploited and killed everything that stood in our way. We have to get to tolerance, and then I think we can make some progress.
I think many of us are seeing how fast humans are changing the world, and humans care. They don't want a destroyed Earth. But I don't think you get depressed if you're fighting with some hope in your heart.
July the 1st last year was my 50th anniversary in the Serengeti. Oh my goodness me, what is this? It was nice to see the younger people wanting to be there for the oldies. I wanted to not only thank them, but to encourage them that it's now up to them to keep this up.
Joseph.
What made this group so special is that each of us has a pretty private part of the world. Some large, some small, which we understand and love. By understanding nature, it'll make managing and recovering nature that much more of a positive experience for everybody. Nature's not a very peaceful place. You know, the sooner you recognize that, the better we can understand it, and certainly in the longer term, the better we can manage it, and perhaps even survive it.
With some mystery to me, the greed, and you think you have to want more than you need. Until you have it all, you won't be free. Society, you're a crazy breed. I hope you're not lonely without me. When you want more than you have, you think you need. And when you think more than you want, your thoughts begin to bleed. I think I need to find a bigger place. 'Cause when you have more than you think, you need more space. Society, you're a crazy breed. I hope you're not lonely without me. Society, crazy indeed. I hope you're not lonely without me. There's those thinking more, less is more. But if less is more, how you keeping score? It means for every point you make, your level drops. Kinda like you're starting from the top, and you can't do that. Society, you're a crazy breed. I hope you're not lonely without me. Society, crazy indeed. I hope you're not lonely without me. Society, have mercy on me. I hope you're not angry if I disagree. Society, crazy indeed. I hope you're not lonely